The year was 1779. A man by the name of Leonhard Euler presented his mathematical findings to the Academy of Sciences. The work he brought forth was on a subject called Latin squares. Since then, these quote-unquote magic squares have been used for many more applications in our modern society, even as technology advances. But what exactly are Latin squares? Simply put, Latin squares are a way to represent data on an n by n array of square values based on what is being tested. In Latin squares, the data cannot overlap in any column or row. As a simple example, you can see the letters A through E are all in each column and row, but only occur once. Typically, Latin squares have different formats, such as a 3x3, 4x4, 5x5, etc., based on how many factors and variables are being accounted for in the experiment. But enough of that stuff. It is more important to know the big picture of how these squares can be applied to much bigger things. The most use we get currently from Latin squares is when we use them to calculate ANOVA, or analysis of variance. This technique involves analyzing multiple groups to see if there are any statistically significant differences between the means. ANOVA is used to then calculate a table of values, which we will get into in a moment. Another practical application of ANOVA would be in the world of coding. They can be used in designing error detecting and correcting codes and in authentication. Another use would be experimental designs, which are important in investigating further ways to utilize Latin squares. By studying different experimental designs, new discoveries and applications can be found. The next topic to cover is how to set up Latin squares and solve for ANOVA, an important part of Latin squares. First and foremost, it is important to choose a proper design format based on the unique factors and groups you will be testing in your experiment. The number of factors or groups will decide how many squares are in the n by n format. The next step is to arrange your treatments so that they appear once in each row and column, as discussed previously. Once this is done, you can begin your ANOVA calculations. Using the formula sheet here, you are able to calculate the sum of squares into a table of values that can be analyzed. The typical table of values calculations indicates the group, degree of freedom, sum of squares, including the total, within, and between values, mean squares, F ratio, and p-value. To make this more understandable, here's an example of a Latin square I have designed. Say an engineer wanted to create a new type of commercial jet which was faster and more efficient. It would be testing new fuels, engine types, and body designs to see which combination would yield the fastest speed. The two factors I was comparing was the fuel and the engine type. The treatment I chose was the type of body design the jet had. As you can see, the different treatments are labeled with letters A through E and are placed strategically so that the treatments A through E don't overlap. You can then calculate the ANOVA through the formula sheet or through a statistics calculator. This will allow you to generate your table of values and analyze the data.